So, let us discuss some problems on Cournot competition. So, in this example, suppose there are two firms producing a homogeneous product and the market demand function is this, where P is the price and Q is the quantity demanded. Cost function of firm 1 is this, cost function of firm 2 is this. So, it is CRS and it is decreasing returns to scale, and suppose the firms compete in terms of quantity. So, it is a Cournot competition. Compute the Cournot duopoly outcome in this market, and when firm 2 is not going to produce any output in equilibrium. So, we have to find out this also, right. Now, so from this we get the inverse demand function is this. So, the profit function of firm 1 is profit function of firm 2 where Q1 and Q2 are output of firm 1 and firm 2. It is Q square, I think. It is this. They are differentiable. So, we optimize this with respect to their outputs. So, this we get first order condition implies so this is the reaction function of firm 1, okay. And so here again get this first order condition implies is equal to this. So, we get this is the reaction function of firm 2. So, if we plot these reaction functions, okay, if we are plotting these two reaction functions, so this is when this is equal to 0, it is this is 5, and when this is equal to 0, then because when Q1 is equal to 0, it is going to be this point is 5 minus C1, and when Q2 is going to be 0, then it is this is. So, we take common because this is equal to 0. So, this is 5, okay, what I am doing. See this 10 minus 2 C1 equal to Q2. So, this point is 10 minus 2 C1 and this point is 5 minus C1. It is this, and this reaction is Q is equal to, this is 10 and this point is suppose 10 by 6. And these two intersects here. So, this is the Nash equilibrium, and we get it by solving these two reaction function. So, it is 10 minus 2C1. If we do this, we get this. This is output of form 1. So, this point is 50 minus 12C1 divided by 11, and this height is, it is 10 minus Q1 this. So, it is 10 minus 50 minus 12C1 . C2. So, this is, we can again write this 10 plus 2C1 divided by 11 this. So, these are the two pure strategy Nash equilibrium or Cournot Nash equilibrium outcome of this game, and we can plug in them in the profit function here and we will get the profit. Now, here again we have to find when form 2 is not going to produce any output in equilibrium. So, so this is the reaction function of form 1, right. Now, it is not going to produce any output when. So, when when it is this, suppose this is the reaction function of form 1, which is given by this point, or see. Okay, the question is this: when form 2 is not going to produce any output in equilibrium, when form 2 is not going to produce. So, see here it is, this is the Nash equilibrium outcome. When do we get this? When this is less than this and this is less than this, right. Now, this is the reaction function of this. So, this has to be so much here that it has to go below it, then only it will not going to produce anything. But and it is not this diagram. Okay. So, an output for this equal to 0, C has to take some negative here, which is not possible. So, that is why form 2 always produces positive amount of output always, but form 1 may produce 0 when C1 is sufficiently high, that is when this is, or this line is just like this. So, if we have a reaction function of form 1 and this is the reaction function of form 2. So, form 1 will not produce anything, form 2 is going to produce this much amount of output then. But since we cannot reduce this below, put this curve below this, or we cannot have this curve greater than this. Why? Because if you look at this point, this is 5 minus C1. So, it cannot be greater than 10. So, that is why we cannot have this curve lying above this curve. Okay, reaction function of form 1 lying above the reaction function of form 2. So, that is why farm 2 is always going to produce some positive amount, but farm 1 may not in this situation when C1 is sufficiently high. Okay. So, we get this. Now, next solve another problem. This is slightly involved problem. Suppose there are two farms, farm 1 and farm 2, and they produce a homogeneous product, and market demand function is this. A is a positive number and Q is the quantity demanded, P is the market price. Suppose the farm can choose between two types of cost function. Its cost function can be of this nature and cost function can be of this. Both has this option where D is greater than C and H is less than F. So, here in this cost function, marginal cost here is less than the marginal cost this, but here fixed cost is greater in this case than this. And suppose there is Cournot competition between farm 1 and farm 2, and the farms choose the cost function and quantity simultaneously. Okay. So, these two decisions are taken simultaneously and compute the Nash equilibrium outcome of this game. Are the farms going to choose the same cost function? Okay. So, these are the questions. Now, we have this specification. So, choosing between two different types of cost function, it means choosing different type of technique or different combinations of input bundle to produce the same amount of output, or to choose a different technology, or to choose in such a way that the setup cost is also here different because F and G. Okay. So, there are many possibilities which may give rise to this situation. It mainly because of two different production function, or it may be two different types of price of inputs, or it may be different plant sizes that we have discussed, that is the one land plot is big, another land plot is small, and they have same they can choose between machines and labor, both of them are variable, all these are possibilities are there. Now, in this case, suppose both farms 1 and 2 choose this production function. Then profit of farm 1 profit of farm 2 this. So, we do the usual process. So, the reaction function of farm 1, from this we get A minus Q2. This is the reaction function, and the reaction function of farm 2 is so. If we solve this, we get the Cournot outcome as we have already got this, and in this situation we know profit of farm 1 is it is this, right. Now, if we look at the reaction functions, and this is the point, this point is this, right. Now, suppose both the firms choose this, then again we know what is going to be the reaction function. It is this, and so the outcome is so profit is this. And in this reaction function, we will get D is greater than C. So, we will get a line like this, A minus D, this is A minus, and this is this A minus D, this point is A minus D by 2. So, this is the outcome, right. Now, if firm 1, if any one of them chooses, suppose firm 1 chooses this and firm 2 chooses this, then what is going to happen? Profit of firm 1 is yes, profit of firm 2 it is this, and the reaction functions of firm 1 is going to be and reaction function of firm 2 solving these two, we get then Q1 is A plus D 2 and Q2 is A it is this. So, and you can look at profit is also this is for firm 1 and for firm 2 it is this. And if we look at this diagram, reaction function of firm 1 is this, reaction function of firm 2 is this. So, this is the outcome. So, this is when we are in case 1, this is case 2. So, this is case 1, this is case 2, this is case 3. And case 4 is, so we will just get the opposite. it is going to be age, because in case 1 farm 1 is choosing the age. This is farm 1 and this is farm 2. Okay. So, we get this. Now, we have to compare this profit, and these decisions are being taken simultaneously. So, it is something like this. So, this is case 3 and this is case 4. So, now when we can have this case or this case or this case or this case. So, when we have this case, that means farm 1 has chosen this, its reaction function is this, because its cost is, marginal cost is C, and farm 2 has also chosen marginal cost such that it is C, and they have got this here. So, then farm 2 has two options, either to choose C or it can choose this two. If I fix the year of farm 1, suppose this is the year, it has two choice, either to choose this or to choose this. Now, how we get this? Get which one is chosen? So, suppose farm 1 chooses this. Okay. Then farm 2 profit, it has to compare between these two cases, case 3 and case 1, case 3 and case 1. So, the profit of farm 1 in case 1 is, and profit of farm 2, and profit of farm 2 in case 3 is this. When it is going to choose this, it has to compare between these two. When it is possible, when this is greater than this, and this implies f minus h should be this. So, this implies that f minus h so this implies f minus h should be greater than this. So, this we know f is greater than h, but the difference should be greater than this. If this is the case, then when farm 1 chooses this, farm 2 chooses. So, if this is the case, when then if farm 1 chooses CQ this, then farm 2 chooses this as the cost function, right? Or if this is not satisfied, if then farm 2 both will, if farm 1 chooses this, then farm 2 chooses this only. If this, then if farm 1 chooses CQ1 F, then farm 2 chooses CQ2 plus F. It should be H. Now, if firm 2 is suppose choosing this, if firm 2 is choosing this, given firm 1 has chosen this. So, is it optimal for firm 1? To find out whether that is an Nash equilibrium. So, we have to compare this with firm 1, this point, this should be so suppose firm 2 has chosen this, then we have to compare firm 1 whether it will choose this point or this point. This point or this point. Oh, not 4, 2. It has to be 2. So, then this means it is this. So, then it means it is this. So, again this means it should lie here. So, if this is the case, then if firm 2 chooses this cost function, then firm 1 chooses it has to be H, chooses this cost function. So, we get that if this is less than A minus C, T minus C 4 by 9, and if this is greater than A minus T into D minus C, if it lies here, then the outcome is either case 3 and case 4. Both can happen. Either firm 1 chooses this cost function and firm 2 chooses this cost function. So, this is the case, or firm 1 chooses this cost function and firm 2 chooses this cost function. So, this is the case. And if this is greater than, if this is greater than this, then we have case 2. Both firm chooses this cost function, and if we have this less than this, then we have case 1, and both firm chooses this as the cost function. So, what do we get? We get many possibilities. So, we have one situation where we have a symmetric situation, that is case 2 and case 1. We have this when the difference between the fixed cost is either sufficiently high or the difference is sufficiently low. case 2 when it is sufficiently high, case 1 when it is sufficiently low. When it lies between a range, then we have an asymmetric situation, and it is this. Firm 1 chooses first type of cost function and firm 2 chooses second type of cost. This is 1, that is case 3. And we may have this case also. So, we have multiple Nash equilibrium here in this situation. See, with simply introduction of a choice over the cost function, that is, if you have choice over cost function, that means a choice over different types of technology or different prices of the inputs, then it will break that unique equilibrium that we get. Because if you look at this case, so we have these 4 possible outcomes now, right, depending on different, and either we can have this as a unique outcome, either we have this as a unique outcome, or we can have these 2 as a multiple outcome, right, because if when this happens, we will also have this, right, but either we can have 1 or we can have this 2, okay, this case. So, depending on the variety of the cost function, and which we get from either production function or from the prices of inputs. Okay. Thank you.